I don't have any childhood snaps of showing my allegiance to the Great Barrier Reef. I did go to Green Island when I was 10. But I did my PhD on dynamic flows out of tidal limits, and that was picked up by Eric Belansky from Ames to explain some of the dispersion characteristics that passes in between the reef. I was really encouraged in a previous session to listen to Eric Fisher picking up on some of that. You may not know that I did some of the original work, but okay. So that's my connection. So a very limited connection. The other aspect of myself and my colleagues is that, well, not Robert, but I'm an engineer. I'm a civil engineer and a coastal engineer by training. And my observations of coastal engineering and the reef are that they've been quite limited. There's been a fantastic bit of work done at the University of Queensland over wave transformations, over reef platforms and around coral atolls. Work at JCU with Kevin Stark and Bruce Harper about storm surge under cyclones. So there's been a connection there, but not a strong one. So my observations of the last couple of days have been interesting. I've heard things about the need for field trials. I've heard things about, from just about everyone, the need to collaborate on what we're doing and the imperative to start now. I think it was Lena Bay that was talking about prioritising, optimising and innovation. And as David Mead pointed out, that's a real engineering attribute, and I think that's something that we can bring to the equation. The thing I'd like to add is that we need to act without 100% of the knowledge. Now, I don't want to alarm you, but the structural engineers that designed this building didn't have 100% understanding of the way this building would behave. I can assure you it won't fall down because we always put a factor of safety into that. But you need to take action, to make judgments, to make a decision based on limited information, and we can't wait until we have the full story from, in terms of the reef. And the stuff that's happening in the RAP program is a really good move forward in that context. The only thing I haven't heard in the session so far is the question of life cycle analysis. Lots of really great ideas, inventions, which worry the life out of me in terms of the carbon cost of actually creating the intervention. And there was a good talk in the earlier session where they clearly pointed out that you don't need a coal-fired power station to do one of them, but it's still a question I think that needs to be addressed. So as a coastal engineer, we really understand the impact of reefs on coast. There's a little small one that's caused an impact on a particular section of shoreline. And here's a big one. The city of Geraldton is basically a tombolo created by the reefs offshore in the distance and near shore. And if climate change causes wave action over those reefs, maybe Geraldton's in problems. So we, as coastal engineers, deal with this kind of thing. How do we tackle it as a coastal hazard, whether it's climate change or just natural processes? Well, the usual thing we do is look for options, and they're simplified into three. We defend, we protect, we build walls, we do things like that. We accommodate, we just accept it and put our houses up a bit. Or we run away from it and we retreat. Well, those kinds of approaches can be, in a sense, applied to the Great Barrier Reef. So, can we defend? Well, the answer to my mind is no. Certainly not the scope of this symposium. I think we need to get the Donalds and the Tonys of this world to change their attitudes, or else we're not in a position where we can defend. The pressures are so global that there's nothing you can do. You can't build a dirty, great big Mexican wall to keep climate change out. So that one's off the agenda. Retreat is completely unacceptable. We've heard so many talks, the talk by Bose yesterday about the value of the coast, we've heard talks about the ecosystem values, the social, the cultural values. Retreat is unacceptable, so that just leaves us to accommodate. And our view is that we need to look at place-based immediate action based on collaborative transdisciplinary science, engineering and investment. And we've heard some good examples touching on this when the proposers talk about artificial reefs integrated into natural systems to give them a better chance to recover, those kinds of things. So that's how we would look at it from an engineering point of view. What's the academic role in this? Well, as academics, we are constrained. We're constrained by self-interest. We've all got to get promoted. You've got to write your paper. You've got to get your research grant. But we need a paradigm shift in that kind of thinking, in my view. And I want to have a quick look at where I think we're at the moment. And I like the adaptive management framework process to dealing with problems, whether these small-scale problems or large-scale problems, where we set a goal. We know what the goal is here. We've got to restore the reef. We've looked at identifying the factors. We've looked at identifying gaps and all those kinds of things, and we've collected a massive amount of data, 10,300 papers on coral alone, I was told yesterday. But how do we get past that position? There's a block there. We've got to move on, and we've heard a number of talks about how we move forward. And I guess our team here is proposing one particular way to move forward. We need transdisciplinary collaboration. It's no good marine biologists sitting in the marine biology lab doing marine biology without understanding the context that the marine biology might have on the next level of the activity. We need to work together, and the same goes for people at the other end developing an intervention. We need outcomes-focused research and education. We need to move away from funding for the specific particular research topic that you have to linking that to an outcome. And we need to share knowledge in a way that perhaps transcends what we're doing at the moment. And one of the key things I've noted as a coastal civil engineer embedded in a faculty of environmental science for 20 years at Griffith University, there isn't any common language. I've heard it the last couple of days. We've had experiences with interns from marine science programs working from an engineering context, and common language is one of the key things. What are you talking about? How do we interrelate the activities that we're doing to each other? Knowledge is a key, and on the Gold Coast we developed a thing called the Coastal Knowledge Hub, and the whole idea is to learn lessons from the past. All those cars were dumped in the 1960s to protect beaches. It's not a really attractive option, nor a very effective option. And the Knowledge Hub is based on 50 years of research on the Gold Coast, and a lot of grey-haired old fellows like me who are just about to retire or have retired, and we lose their common knowledge. Decision was made about 5 years ago to do what we could to bring it all together. Now, the key about knowledge is that if you don't have it and you don't learn from it, you end up in this situation here, where instead of you have cars on the beach, you have swimming pools. Because down in Sydney, they were faced with the same issues we were on the Gold Coast, but they ignored most of it for 50 years. They had the same starting point of massive storms in the 60s, and whether it was community resistance, government resistance, or a lack of really understanding the problem, in 2016, this is what happened in Sydney. And that's not a good look. That photo has been used just endlessly of late to demonstrate what you should and shouldn't do. So how might a knowledge hub look on the Great Barrier Reef? Well, these are some points that are relevant to our knowledge hub on the Gold Coast. And the key is that it's not just data about the marine biology or the ecology or whatever. It has to be all data sources. We've heard some wonderful stories from the Indigenous community here in this conference. That information needs to go into a knowledge hub. We need the information about the paleo changes that have occurred on the reef to go into the knowledge hub. And I would argue you need to sit down with old fishermen and the like who have particular anecdotes. That needs to go into the knowledge hub. Now, it's not just a collection of information, it's got to be an interpretive process, so you actually learn from the acknowledgement that, from the information that you've got in there about what not to do and what to do, and what things have worked and what things haven't. And then we've heard about a couple of similar kinds of ideas here. The Reef Resilience Network was one that sort of was attempting to bring this together. In the coastal setting, the National Climate Change Adaptation Research Facility developed a similar web-based system for coastal systems. If we don't use that information, we run the risk of making further mistakes into the future. Collaborative research, as I said, I think there needs to be a shift in funding to outcomes. Back in the coastal CRC days, those of you who remember that, the CEO set rules that said unless you had a stakeholder interest in your research and it was a multidisciplinary project, you didn't get any funding, and we need more of that. That seems to have died off a little bit. We need transdisciplinary teams. Within the work that we do on the Gold Coast, we have marine scientists, the engineers, physical oceanographers, people from our business school, and most recently architects involved in the kind of problem solving we're trying to attempt on the Gold Coast that Angus will talk about shortly. So, and of course tourism researchers as well, the likes of Susan Becken from our Institute of Tourism on the Gold Coast get involved in the kind of things we do. I'm the director of a Centre for Coastal Management, and we've been doing this kind of thing now for 20 years. And we have a whole raft of people within the centre tackling problems right through to economic and social issues related to the coast. The key about it is it's solving problems set by our principal partner, the City of the Gold Coast, and our other industry partners. We don't define the problems, they define the problems. We need to move more in that direction. And that's been going for 20 years. When I started this, I had bright red hair because I thought it was a great idea, but after you've been dealing with a local government, getting money out of them, or any government for the last 20 years, you tend to grey a little. And I think it's scalable. It's a model that is scalable. It seems to work very well in the kind of problems that we are faced generally in the coastal zone. Moving on to education, I've heard no talk about education in the seminars to date, in the conference. And my point I want to make about education is that there needs to be a shift in disciplinary focus. I'll give you a great example. I was the head of environmental engineering at Griffith University in the early 90s, and my students sat in classes with environmental scientists and planners in first year doing ecology. And one particular lecturer one day got them, the engineers, to stand up, and she said to them, these are engineers, they have no right to be here. Engineers drive bulldozers through rainforests. Now, I don't have a bulldozer licence. Not all engineers think that way. You've seen the kind of things that David Mead's been talking about. He's an engineer, he doesn't think that way. But it seems to be a mindset that I think is still embedded in a lot of our educational programs. And I'm not saying we all need to be training people into transdisciplinary thinking, but at the very least, all of our programs need to have be taught an appreciation of the different perspectives that come from different disciplines. And of course, the other factor in there is, if you think about it, David Wackenfeld the other day said that if we make 1.4 degrees by 2030, we've got some sort of a hope. That represents 12 cohorts of new students entering your university systems between now and 2030, which equals about 4 to 8 cohorts of graduates who are going to become practitioners, depending on whether they do undergraduate or postgraduate degrees. They're the people that are going to be taking this on and moving forward with all these things. We need to start getting them thinking about these problems in the transdisciplinary space right now. So my message to you is to go back to your Vice-Chancellors and to get some permission to maybe structurally change some of your courses and programs. And of course we need that integration all the way down the coast, which is already happening. So how does education and research work with the implementation of particular problems? Now this is a diagram of a typical design thinking process, and where we're at the moment, we're starting thinking about prototypes and prototype testing. That needs to be done with the involvement of research and education, whether it's in getting students involved to assist with their education project, or getting the academics, not just to stop when they've done their science, but to keep going into integrating with that project. And just to end with an example of the way we look at this on the Gold Coast, 20 years ago, an idea came of this concept of what we call IONS, where you don't just build things, you've got to build them so that they interact effectively and enhance natural carrying capacity. That's a picture of the Narrowneck Reef, which is a coastal protection structure, which was designed specifically not to act like a pile of rocks blocking sand. It was designed to integrate in with the natural flow of sand around that. And it's a concept that's used worldwide with different names, building with nature, and I think it should be applied to any intervention that occurs on the Great Barrier Reef. This was an award-winning project, and it had a very effective outcome for what its purpose was. But it's an approach that we have that Angus will now talk about in terms of how we see moving forward in the implementation of particular solutions. Thank you.